Hey everyone, welcome back to a series where we deploy Nomad on Google Cloud. This is episode 4, and today we're going to mount a storage bucket using a Fuse driver. I'm accompanied by Chris, who you've met in previous episodes. Want to say hi to the audience, Chris? Nice.
Yeah, what's up?
So we're going to deploy a static website by mounting a Google Cloud storage bucket and using a Fuse driver to get a simple web page. And to expose that on the public load balancer that we created some time ago. Chris, what do you need to mount storage to the Nomad cluster?
Yeah, so Nomad doesn't come out of the box with any type of persistent storage because it's a job scheduler, right? So this is functionality you have to add yourself. Luckily, there is this notion of volume types and plugins. So you can choose what type of storage you want. Some are better for certain types of jobs. And then you install a driver for that in Nomad. And once you have the driver, you can actually define a volume using the driver. And then that volume can be attached to your jobs. So those are all the things we need. I think since we're in Google Cloud and we like to make use of cloud native services, I'd like to use Google Cloud Storage. It's very easy. It's one of the easier drivers to install, but it has one very big benefit, and that is that it supports multi-node read and write functionality. So it means you can mount the same volume in all allocations of your job. And all of those can then read and write to this central storage. So I think it's very powerful for something like a static website where you just want to serve the same content from a single storage location.
Exactly, nice. And what are some of the alternatives out there compared to or opposed to Google Cloud Storage?
Yeah, so there's more classic sort of disk type storage, which you can do in both Google, other clouds, but also on-premise if you have a storage array with disks. For that, you can define disk volumes and attach those to your jobs. You can go very far with that, as even to define which storage disks arrays are in which data center and which geographic region and all that kind of stuff to make the Nomad planning better. There's also network file storage, which could also live on your own data center on-premise, or in Google Cloud, you could use a service like FileStore to get network attached storage. And there's also a good driver for that in Nomad. So you have all these options available. For today, I think for the sake of simplicity and because I like endless scaling services, let's go for the cloud storage version.
Cool. Okay. And for the audience, we're going to install a CSI driver. What does CSI stand for?
That's the Container Storage Interface. It's basically a little spec that says these are the options and things that any container storage should expose so that containers can talk to it.
Okay, exciting. So we're going to install one of those CSI drivers specifically for Google Cloud Storage. What are the options for the CSI drivers there? Are they community supported? Are they supported by Google? Are they supported by some other party or third party?
Yeah, so basically a storage driver in Nomad is nothing else than a job as well. And that job runs a piece of software that exposes the container storage interface to other jobs. So in our case, we are going to run a Docker container that exposes Google Cloud Storage as a container storage interface. And in our case, we are going to use a community-built driver because it's the most widely used outside of Google. Google also has their official one, but it's really tailored towards Kubernetes engine. So there's a couple of features in there that clash with Nomad, so that doesn't work really nicely. So we're going to use the community one, which was also the original CSI driver for Google Cloud Storage. So I think it's a pretty safe piece of software to use.
Nice, exciting. Okay, and do we simply just launch a system job, or is it a single job, the CSI driver? Is it multiple jobs? How does that look like?
Yeah. So volume drivers in Nomad always consists of 2 jobs. There's something called the controller, which is like a central thing that orchestrates all the volume activity for that type of volume.
Mm-hmm.
And then there is a system job you deploy on every node that receives these commands and does things like mounting volumes to the local file system when the controller asks it to. Those kinds of operations.
Okay, check.
Yeah.
So I guess in a moment where you and I are going to go write 2 jobs, a fuse controller and a fuse storage node job. We're going to deploy that and then see where we go from there.
Sounds good. Let's start there.
Cool. So Chris and I, FYI audience, Chris and I have a shared editor, which I just popped up on the screen. You'll see us write some code in here. Same for the previous episodes. If you don't see Chris typing, it's because I'm writing. Just an FYI. So we already have a jobs folder with a system folder in there. Should we create a CSI folder in jobs, or should we create a CSI folder in system?
They're technically part of sort of our system that we need. So I think within system sounds good.
So I'll go ahead and create a CSI folder in system, and I definitely fat fingered CSI. There we go. So I guess we're going to start with the first one, which is the controller. So storage controller.hcl. You see where I am in the? I think you should be able to see.
Yeah, it's already open.
Great.
I'm following your cursor.
Yay.
Yeah, so we're deploying a controller here. We always specify our default sort of data center. We only have one, of course, but keeps the scheduler happy. It's going to be a Docker container that actually runs the CSI driver and exposes it to other Docker containers. So it's pretty cool. That is the wrong image.
Oh, I think it is, right? You're right. Yeah.
Yeah, so like I said, Google also has an official image, but it's really tailored towards Kubernetes engine. So if you run it outside of Kubernetes engine, you run into all sorts of problems because it expects certain services to be there. And in our case, they are not. So.
Thank you for reminding me, Chris. I was defaulting to the default, to the official image indeed.
Yeah, so we also need to add an argument here to this container. It needs to know the unique node name that it's running on. If you have multiple instances running, this sort of helps distinguish what is what.
By the way, there's no auto formatting of me writing. I guess it's because we're in a shared editor, but we can format it in a moment.
Yeah, we definitely need to. Otherwise, Nomad will not accept the.
Exactly. Oh, thank you for that.
Go.
Okay.
All right. Yeah. So we have the container running the community CSI driver, and here we have a block called CSI plugin, and this tells Nomad that this job is actually mounting like a CSI plugin. It's sort of a special annotation that Nomad understands, where we give it an ID, which we need to reference in all the volumes that we are going to create. We are going to, in this case, for now, say this is the controller. In a bit, we will also deploy the nodes image, and then the type will be nodes. And we need to give it a mount directory for the container storage interface sort of endpoints to be mounted on. And those are then shared with all the allocations that are going to use the volumes.
Nice. Well, one thing that I thought we were going to deploy this one as a system job as well, but I think the nodes is going to be a system job.
Yeah, correct? So this is a central controller that just orchestrates all the volumes. So you only need a central one for that. You can run it highly available, I think, but it really depends on the image that you're running, whether that's properly supported or not. Okay. In our case, I think, for example, we don't really need that because once the volumes are there, it's all fine. And then the system job we are going to create, which I think we can do right as well right now.
Copy paste the file because I know it's pretty similar.
And that is really the receiving end of the controller. So this job receives instructions from the controller on what to do on every particular node where suddenly volume or storage is needed. And this is attaching, for example, a file system directory to a container in order to get some storage available.
Right on. Okay. And so I just did a copy paste of the controller, I renamed it to Fuse nodes. I made it a system job, and I know it has to run in privileged mode. Do you want to elaborate on that?
Yeah, so for storage operations in Docker, you need elevated permissions. So in this case, we need to tell Docker that this image is allowed to use these elevated permissions.
And we're going to add an additional argument.
Yeah, this version 5 is sort of the version of container storage interface. There's multiple active versions nowadays. V5 is the latest sort of stable one, so we'll just target that.
Cool. Yeah, so I think this looks okay, right?
Let's see, the type still needs to be changed as well to
node.
Yeah. Yeah, looks good now.
Right. Can, one more thing, Fuse nodes. There we go.
Yeah, let's give them a unique name indeed. All right, so let's grab this content. So like we explained in previous episodes, at some point we will introduce a proper CI/CD for jobs. We're not there yet, so for now we're just manually creating them through the administrative UI of Nomad.
Yep.
So let me paste in this little snippet here. Yeah, all looks good. Let's plan it. So this one is happy, so let's run and see what happens.
Yay.
It's deploying. First time it needs to pull the image, of course, so always takes a little bit longer. Well, the very first deployment. All right, there we go. You could even see in the allocation history, which is sort of an event log of this job, saying that plugin Fuse became healthy. So it recognized this controller as exposing a storage plugin. So that's very good. And if we go to storage, we can actually go to plugins. And we already see here the ID that we defined. So our plugin is registered. We can see our controller is healthy 1 of 1. And our node is 0 of 0 because we have not deployed the node jobs yet. So that's what we need to do next in order to actually be able to use volumes. So let's go back to the code and let's open up this nodes job. Also copy that over.
Ship it.
Looks good. So this starts immediately, right? Because we already have the image. We don't need to pull it again. So it's super fast. Already up and running. So every node we have 3 client nodes. So we expect 3 allocations, which is what happened. And if we now go to storage and to plugins, we actually see that the nodes are becoming healthy.
Nice.
It takes a little bit wait for the drivers to boot up. Yeah, there we go. 3 out of 3 are healthy. So our storage driver is all ready to go. Everything's deployed. Yeah.
Nice. So now we have the drivers. Next up, I think in our use case, we stated that we were going to create a Google Cloud Storage bucket, have a simple index.html file, and they're serving like a hello world or hello Mars message. So I think we're going to have to create a bucket. What do you think?
Yeah, so before we define and the actual volume, this volume will point to an existing bucket. So otherwise the volume will fail. So we first need to create that bucket indeed.
Okay. I'll go ahead and create a storage.tf.
That's good. Yeah. Yeah. So
what we're gonna name
storage buckets are globally unique, so we need to figure out a name that doesn't conflict with anyone else's bucket.
Naming things is the hardest thing in computer science.
So I think we can just start with the name of our Google project, maybe. It's pretty easy.
I think what we can do is
sort of define a namespace for ourselves that way.
Yeah, maybe we can just use the project ID. Just to make sure it's globally unique. And then static.
Yeah, it seems pretty good.
And I think we also want to create an object in the bucket.
Yeah, if you want to serve a static site, let's at least create like an index.html file that can be served so we can test if everything works. I think our static site job will be just a Docker container running Nginx. So index.html will automatically be picked up and served by default. So that's nice. Cool.
Cool.
All right.
And one more thing. So Nomad, of course, like a service account that's associated with the Nomad agents, the clients specifically require access to read and write from his bucket. I think we should make sure that Nomad can read and write to the bucket.
Yeah, we need to add those permissions indeed. Otherwise, you get an error once if the volume is trying to actually mount the bucket into your job. Yeah.
Let me create a storage member resource. Google storage IAM member, and that would be. I gotta look on the registry for all the arguments. I think it's member ID and project, but let me just make sure.
Yeah, I think it's bucket and role and member. Yeah. I think it needs admin, right? Because we need to also write to this bucket.
Can you recall the name of the service account? Let me quickly. Oh, it should be
I think it's Nomad. Yeah.
Just Nomad agent.
We can have a quick look. Google Service Account.nomad agent. Yeah, so that is the service account that our entire cluster is using to contact Google APIs. So that's the one indeed we need to target here. Yeah.
Cool. Okay. I hope I didn't fat finger anything.
It looks pretty good to me. So we apply this.
Yeah. I think I made one oopsie, but I think it's fine. I created a regional bucket. We have a regional cluster. We could have opted for a multi-regional bucket as well.
Okay, yeah. Regional is a bit cheaper. I think since our cluster is already regional, there's no real point in adding even more availability on the storage layer because it doesn't really add anything for now.
No.
All right, 3 to add. That looks pretty good.
Ship it.
The name, HashiCorp Nomad static, also looks good.
Ooh, nice.
All right, awesome. We can have a quick peek in Google if everything worked. Cloud storage.
Sanity checking Terraform.
Yeah, HashiCorp Nomad static, and then we have our index.html file, so looks pretty good.
Yay. Now, the bucket, of course, is like by default, Google creates a pretty private bucket. We didn't specify anything like it has to be open to the whole world and whatever. That's correct, right? That we don't need to do that.
Yeah, it's closed by default. Yeah,
exactly. Because Nomad is going to read the object and serve it. We don't need to create a public bucket as well.
Mm-hmm.
Simply getting the object from there. Okay. So next up, I think would be to create the volume specification where we're pointing to the bucket to get the file from. But what really is a volume specification and why do we need it? So we have the driver.
Yeah.
It's just there to be able to act as that container storage interface in order to communicate with Google Cloud Storage. We have the bucket. We have the object. Now we need to link things to the Nomad cluster. And from my understanding, you need a volume specification for that. But can you elaborate a little bit?
Yeah, so for Nomad, in order to be, in order to add volumes to allocations, and an allocation is like one instance of your job, right? So if you have auto-scaling and you say my job needs 3 instances, you have 3 allocations. And each of these allocations needs a volume attached if you specify that. And that needs to come from a volume sort of definition that tells Nomad, this is my volume, it lives here, this is the plugin, CSI plugin that serves this. And these are the capabilities it has. With storage, you can think about minimum size, maximum size, and capabilities like can multiple instances read from this store volume? Can multiple instances write to this volume at the same time? So these are all capabilities of a volume that need to be defined somewhere.
Right on.
The nice thing about Google Cloud Storage is that it is multi-node, multi-writer. So this means that multiple instances can read and write to and from this bucket at the same time. So if you're serving a static site and you're changing the content in your storage bucket, it will update on all instances of your static sites at the same time. So I think that's pretty good behavior for what we want here.
Nice, sure. Yep. All right, let's go ahead and create a volume. Now this volume specification has to be registered at some point with Nomad as well, right?
Yeah, so we write a little bit of HCL code that sort of defines the volume, and then we need to tell Nomad to know about this HCL file.
Okay.
And there's currently only 2 options to do this. You cannot do this in the user interface yet. So you need to push it via either the REST API or the command line interface. We'll be doing the latter because it's a bit easier. But as you might reckon from our earlier episodes, our cluster port lives behind IAP, Identity Aware Proxy. Mm-hmm. So we cannot simply just reach it from our computer over the internet. That would not be very secure, right?
Yeah.
So for us, in order to reach the Nomad endpoint from the CLI, we need to set up an identity-aware proxy tunnel from our computer to one of our Nomad servers. And for that, we need to create some extra Google resources to, first of all, allow our service, our user account to set up this tunnel. So we need an IAM permission for this.
Mm-hmm.
And then we need to allow firewalling so that the identity-aware proxy is allowed to forward traffic to our compute engine instances that we created in the first episode.
Yeah.
And then we actually need to set up the TCP tunnel, and then we can use the CLI to talk over that tunnel to our Nomad cluster and declare the actual volume.
Exactly. And an alternative option as well, just for the audience, is to use the Nomad provider. In that case, because we are protecting, and like Chris said, our Nomad cluster with identity-aware proxy, you would have to be able to proxy into the Nomad cluster to run to make use of the Terraform Nomad provider. In our case, but note it is an alternative to be able to register the volume as well.
Yeah.
I'm going to create a volumes directory. I think it's not a job, it's just a volume. So I'm creating a volumes directory.
That's good.
And in that volumes directory, I'll just declare something like a file called fuse.htl or just fuse.htl. Okay, so type is going to be CSI. Maybe you can just comment on or explain to the audience what I'm writing out.
Yeah, so it's a container storage interface, so the type is always CSI. The plugin ID is the one we just specified when we deployed our controller. So we named our CSI plugin Fuse, so that's what we need to use here. Then we need to give our volume a unique ID and name. The ID is sort of guarantees uniqueness across your system, and the name is just for visibility purposes. And an external ID, in the case of cloud storage, this is the name of our bucket. So that's what we specified here. If you use another type of storage plugin, this external ID needs to have a different value. So you need to look up the documentation of the plugin you're using to know what the correct value is to put there. Let's then define our capabilities. In our case, because our type of storage can do everything up to multi-node, multi-writer, meaning multiple instances can write to the bucket at the same time. This is not a problem for cloud storage. This means we can add any capability lower than this as well. This just makes it easier for scheduling, that if you at some point define a single instance job, that Nomad also knows that this storage type can be used. Yeah.
Cool. By the way, I initially started with naming the file fuse.htl and the ID and the name fuse.htl, but it's a bit meaningless, fuse.htl. Whenever you create a volume, you should be more explicit on what the volume is. Because our volume is going to be a Google Cloud Storage bucket. The name of our Google Cloud Storage bucket is HashiCorp Nomad Static. I'm using that everywhere to be a bit more explicit about it. And indeed, this plugin ID is Fuse, because that's the name of the plugin that we just deployed, which is that CSI, those CSI jobs controller and the nodes. We named that Fuse.
Yeah.
Okay.
So now we should be able to send this to the cluster if we have all the communication in place, of course. So that's something we need to take care of.
That's a good one, because now you want to tunnel into the into one of the Nomad agents. You're going to tunnel using Google Identity Aware Proxy, which is TCP traffic over port 22. meaning we're going to need a firewall rule for that, and you're going to need an IAM permission, something like identity where proxy tunnel resource accessor. So let's get back to our feepc.tf and figure out the identity where proxy firewall rule. So I will declare a local on the top of feepc.tf, which is going to be the CIDR range for identity where proxy. Maybe you can briefly explain why we do this and why we need this specific range.
Yeah, so Google Identity Web Proxy is a Google managed service, so they run a central service somewhere to add this functionality. And they have reserved this CIDR range for people to sort of whitelist your firewall rules if you make use of Identity Web Proxy and you want to forward Identity Web Proxy traffic to your own networks. So then you need to add a firewall rule that allows this reserved range. Yeah.
Quickly adding the docs as a comment. Create firewall rule. Okay. So that's done. Now we're going to have to create the firewall rule. So if I scroll a little bit down to our other firewall rules, which is, I'll do it. I'm going to do it after allowing private Google and restricted Google access.
Yeah, that makes sense. Yeah.
Just a comment. Firewall. Oh, resource. I didn't know when I started typing firewall.
Yeah, so this is just a normal firewall rule in Google. It just happens that the source range is one of the reserved ranges from Google for IAP.
Where can folks find those reserved IP ranges?
It's just in the documentation from Google. So if you go to the Google Cloud documentation website and you look for IAP firewall, it will be available there. Or you just copy the range from our stream, also fine.
Yeah. Direction is ingress because it is only ingress traffic.
Yeah.
And source ranges is going to be referring to that local.
Yeah, now we're going to use.
Yeah, so I said port 22 in the beginning, but I think I'm wrong. I think it's just any TCP port, but correct me if I'm wrong here.
So it depends on what type of tunneling you do. You can do SSH tunneling only, and specifically only allow that. And then you also specify here port 22. But in our case, we need to do some commands to port 4646, right? The Nomad API port, which is what the CLI talks to. So we also need to specify that port. And then there's also some magic from Google side to make sure that you're not running out of available ports. So it might sometimes do port translation. So it's pretty safe to just specify all ports on this protocol.
Yeah, exactly. Yeah. Cool. So that's the firewall rule. Now, you also need IAM permissions because Identity Ware Proxy is a managed service. It actually uses Google Cloud IAM to verify that you're allowed to actually tunnel into a particular resource. In this case, the resource you're going to tunnel into is going to be a VM, one of the Nomad agents. So we are going to create I think in im.tf, we are going to copy paste. Are you in im.tf by any chance? Oh, yeah, awesome. So we have an existing IAP HTTPS resource accessor for all the Nomad admins that we have. Now, the HTTP resource accessor is for Chris and myself to be able to open the Nomad UI, as you've seen in sometimes during these episodes. Because that is also protected by Identity Ware Proxy. But that is on the browser doing HTTP call. Now we're going to, like we said, tunnel into an actual resource. And for that, instead of HTTP resource accessor, there's also a tunnel resource accessor. So I'm going to copy paste this block and rename HTTPS to tunnel.
Yep. Yeah, so this is sort of a sub functionality of IAP, for which you need a separate IAM binding. Yeah.
What do you think, Chris?
I think this looks all good. This should give us the access we need. Yeah.
Okay. Let's go ahead and ship it and try to push the volume specification.
Sounds good. Let's apply the Terraform code first. 3 to add, so that's for our users to do the tunneling, and we have the new file rule, so that looks good.
Yeah, and audience, sorry if we blurred out the Terraform apply, because our email addresses are specified in the plan.
Yeah, we'll make that sort of section at the bottom invisible.
Yeah.
We'll clear it out so it can be visible again. All right. So that is applied. So we should be able now to set up the tunnel and actually talk to our Nomad cluster from the CLI.
Exciting.
So for that, we have a nice command. We're using the gcloud command line tool first to set up the tunnel. And then we're using the Nomad command line tool to push the volume specification over that tunnel to our Nomad cluster. Make sense?
Yeah.
All right. So this is the command to start this tunnel, start IAP tunnel. Then we need to target an instance name, which is a Google Cloud Compute instance. So let's look that up.
Does it matter which instance we're targeting for pushing this volume specification? We just register it with Nomad, or
we have clients and servers. Nomad CLI commands are always sent to servers because they need to distribute across the entire cluster. So it's best to pick one of the servers for this.
Okay.
So I can just pick the first one here.
Exactly. But to clarify, like registering a Nomad volume, you can do it with any server, and the servers will handle that the volume spec is registered on every server.
Yeah, they always communicate and work with each other. It's you can even run a single server if you want, but then your cluster is not highly available.
Yeah.
Then we need to specify a port. Well, Nomad's API port runs on port 4646. Then we need to specify the other end of the tunnel on our local machine. We also need to give that a host name and a port. So that would be local host port. That would be localhost, and then also let's pick the same port because the CLI is pre-configured on this port, so that just makes it easy. And we need to specify the zone where this compute engine instance is running. So let's have a look. It is in Europe 4C.
Nice.
And then we also, let me put an is between that. And we need to specify the project that we're deploying to. That is HashiCorp. All right. So let this set this up, and then Google will tell us if the tunnel succeeded or not. Oh, that was pretty fast. It's listening on port 4646, meaning that the tunnel is healthy and everything is good to go.
Nice.
So we need to keep this running. So we need to set up a separate terminal tab for us to run the other command. And that would be a Nomad volume register. And that tells Nomad to register a volume that you've defined in an HCL file. And now we need to target the file that we created, and that would be volumes/HashiCorp nomad static.html, right?
Yep.
I think this is all we need.
I hope so. I'm just thinking out loud whether it's gonna recognize the.
Yeah, so by default, Nomad looks at localhost 4646 to execute commands to a cluster.
Okay.
And since we have the tunnel targeted to that location, it should work.
Should be good, right?
Yeah. Okay. Let's run it, see what happens. Oh, there we go.
Oh,
volume
nice.
Nomad static registered. So everything looks good, and we can actually verify this in the admin UI of our cluster, because unfortunately you cannot yet create volumes in the UI. You can see which ones are there.
Nice.
So for this, we just need to go to storage and then volumes.
Yeah.
Here we have our HashiCorp Nomad static volume.
Available
the
to
folder that
everyone.
operates it is also healthy. And it is not allocated yet, because that's something we'll do right after this.
Nice. Very, very, very nice. So that means we now deployed, just quickly recap, we deployed our container storage interface driver, which is the Fuse driver, which is a controller job, which is a single job and a system job for nodes.
Yeah.
We created the bucket where we stored a index.html in. We configured identity-aware proxy firewall rules and IAM permissions for us to be able to push a volume specification, which we defined, which is a volume specification pointing to the bucket that we created. And now that once that volume is registered, we can actually, I guess, create an example job on /public or /static that reads the object from the storage bucket and exposes it, right?
Yeah. That's yeah. Now we have a nice volume. Let's actually use it for something useful.
Nice. I will go ahead and in jobs create a a static site.html job. So I'm going to write it out. Maybe you can just share with the audience what I'm doing meanwhile.
Yeah, so we're creating a new Nomad job to run a static site, just as an example of how to use storage. So this is a pretty normal job, not a system job or anything. It's just like you would deploy any other website. Yeah, let's indeed put 3 of them here just to illustrate that the storage that we created works with multiple instances of your job, multiple allocations. Actually, I think that the network needs to be inside the group block.
Oh, you're completely right. Yeah. Now I lost track of. So this one closes this one. This one closes this one. Need one more here. Okay. Then here we're going to define a surface. Thank you for formatting my stuff. It doesn't auto format.
Yeah, the auto formatting is not working correctly yet. So yeah, indeed we need a network, just like any other job that we want to expose. It's network mode bridge, port HTTP port 80, because that's the port we'll be exposing on our container. And we'll be hooking this up to traffic, which is the ingress controller that we deployed in a previous episode. So we can actually reach this service from the outside.
Yeah. Can you briefly recap to the audience what we did in that episode and why we're using port 80, if that's possible?
Yeah. So we have a load balancer running on sort of a public endpoint, and that load balancer points to port 80 on every client node on which we have exposed traffic, which is the internal load balancer in our Nomad cluster. And this means that every service we want to expose to the world needs to be registered in traffic, and that's done via these service tags. And traffic automatically scans deployments for these, picks them up, and then creates some needed routes to expose the service.
Yeah.
So we want to expose it on our /static path. And we also want to strip this /static prefix because we don't want this part of the path to be forwarded to our actual service, because then our web proxy will be confused because it doesn't know about where it's actually deployed.
Yeah. And just for the audience, could you briefly explain the difference between the service and a task?
Yeah, service is basically there for routing purposes, and the task is your actual container.
Yeah.
Yeah. So this is a pretty common pattern in any load balancing or forward or reverse proxy type of setup.
Mm-hmm. Cool.
So yeah, in our task, it's going to be a Docker image, and we're going to have a volume mount where we point to the volume we just created, and then we say within the container, it needs to be mounted at this path. Can be anything. /static is pretty simple, so let's put it at that.
So indeed, in the volume mount, we're referring to a volume.
Yeah.
I'll call the volume static because I'm declaring it here, and there I'll point to the HashiCorp Nomad static volume. No. It's going to be a CSI volume.
Yeah. So in our group spec, we need to find the volume, which basically targets the volume we just deployed to Nomad. And then in our task, in our Docker job, basically we need to mount this volume in a particular path.
Yeah. So indeed, this is where we declare the volume. Source is where we point to the actual volume that we registered, which was called HashiCorp Nomad static.
Yeah.
If you recall from the from this volume here, HashiCorp Nomad static.htl. Then back to static site.htl, we give it a CSI driver type. And this volume we reference in this volume mount here indeed. And we're configuring an Nginx image, and Nginx is smart enough to look into /static /index.html automatically.
Yep.
So hopefully whenever you go to our load balancer and you go to /static, it would go, Nginx would look into /static /index.html, which is the file that we've mounted and put into the HashiCorp Nomad static bucket. A lot of static. But I think this is good to go to ship as well, right?
We will deploy this. Let's make this plan. Plan looks good, so let's run it. Just going down, downloading the image. All right, we get a permission denied.
Did I
downloading the image? That is very weird because this is a public image. It probably was misspelled.
Yeah, let me double check if I fat fingered the. I definitely did. It's Flash Spice. Yep.
Okay. In that case, we can pretty easily go to the definition again, edit it.
Add an S.
Place it with the correct image and plan it again. And here you can see the actual change. So let's run this, and now it should work.
Luckily, Chris is already used to the fat fingering code.
All right, we have one healthy. Deploying the second one. Also starting up the third one. There we go. 3
Nice.
out of 3 allocations running, so that went very well. So if you now go back to storage, we can actually see that the volume we just created has 3 allocations, right? So it's being used by 3 job instances, which is what we expect. So I think we should be able now to go to our actual website and
I am curious though
of the index HTML that we created, right?
Yeah. I am curious though. What happens if you click on the volume here? I haven't clicked on it yet. I'm just curious what you get to see. Oh, not found.
There's a permission issue here. Not sure. I don't know what.
I broke it. I'm sorry. Should not have asked you to click on it. Nice. Okay. Yeah, but I guess indeed we can go, because we deployed this static site under our public load balancer with a /static. I think we can go to public.nomad/on/Google. Oh, that's a different one, right?
Yeah, so now we're on
that's our echo
demo,
service.
which is the demo job we deployed last time to show the whole load balancer that was still open, so that still works.
Nice.
Now we can go to /static indeed.
Nice. /static, I'm sorry.
All right. Get a page not found. That is interesting. Are we sure that the spec is correct? If traffic enabled true, we have a router static path prefix /static, middleware static strip prefix also /static. Then we attach our middleware to our router, so that looks good to me.
HashiCorp Nomad static.
First is also correct.
Our bucket is called HashiCorp Nomad static, right?
Yeah.
Arms. Okay.
HashiCorp Nomad static. There we go.
Can you look into?
There's this
Didn't
file.
fat finger that, right? Okay.
Yeah.
Does it need a text /HTML? No, I don't think it needs that, right?
No.
Bad idea. Let me also try to do it for my machine. Ooh, I get a 442. What did we break? Oh, I spotted the issue.
Right.
It's my bad. Yeah, it's my bad. I missed out on an S in middleware. I thought it was HTTP.middleware, but it's HTTP.middlewares.
Ah, okay. HTTP middlewares here, I think, right?
Yeah.
Okay.
I was getting like a mini heart attack because we haven't encountered this issue before.
Okay, let's update the deployment. Now it's healthy again, so let's go back.
Hello, Mars. There you go.
Hello, Mars. It's indeed the content that we put into our static site index.html file. So this is being served straight from that bucket file that we created. So that looks very good. Yeah.
Awesome. So we sounds like we're at the end of the episode. We deployed. Do you want to quickly recap what we all did in this hour?
Yeah, so basically our goal was to deploy a static site using some storage. And in order to do that, we needed to deploy a Nomad storage driver, which consists of two jobs, a controller and a nodes agent. We needed to create a volume specification, which we needed to register with Nomad via our identity web proxy tunnel, because we have Nomad running in a private networking setup. And then we created a job for our static site, which pointed to that volume that we registered. And then we exposed this via our traffic ingress controller on our /static path. And now we can see our static website, actually. Yeah.
Nice. Awesome. Cool. That's super exciting. Thank you for working on this with me, Chris. I really appreciate it. Now, in our next episode, I'll leave the honor up to you. What are we going to do in our next episode, Chris?
I think we have a couple of options, but now that we're deploying some websites, we might expect some traffic soon. I don't think that 3 nodes for clients is going to cut it. But we also don't want to run like 10 or 20 all the time, because that's very expensive. So we need to dive into something called autoscaling. And in order to run that properly, we need to gather some metrics about CPU usage, active allocations, just to make sure that our cluster scales up and down properly. So I think next episode we'll dive into aggregating these metrics and creating an autoscaler based on them. Yeah.
Exciting. I think that's going to be really cool. There's a lot of different options on how to do that. We are going to go with the Google Cloud way of doing things. I won't spoil too much on how we're going to do it, but I'm sure, audience, you are going to like it. Chris is going to be part of that episode, of course, as well. I really need Chris for all these awesome things with Nomad on Google. But yeah, audience, thank you very much for watching. Next episode, episode 5, is going to be about autoscaling, aggregating metrics, and making sure that anyone in the world can visit our Healthy Hello Mars jobs website. So yeah, thank you for watching, Chris. Thank you very much for co-building this with me. I'm going to see you in the next episode. Audience, we are going to see you in the next episode as well. Have a wonderful day. Thank you. Bye-bye.
Thanks, bye.